Oh, go ahead.
It's all right. It's okay, Sam. Hey, everyone. Welcome to the Viking Student Skill Sprint. So we are here with the current cohort of Viking Code School students. Viking Code School is a 16-week intensive 4-month training program for anyone who's interested in becoming a professional software developer. We also just recently launched a new part-time flexible program option. You can go to vikingcodeschool.com/program for any details about that. I'm going to hand it off right now to one of our awesome instruction team members, Chris Scavello. He's going to go into the scope of the project, and then we're going to just move forward with the presentations. It's all about you, Chris.
All right, thank you, Dara. So yeah, the students of the full-time program for January 2016 have put together each one, like has went out and they've learned a new skill, whether that new skill be a language, a library, or framework. They had basically the an entire weekend to learn that new skill, put together a demo, and learn enough about it to come in and talk about it for 10 minutes and show the demo, show what they've learned, and teach the rest of the students and all of you, who are watching what that is and how it works and, like what they built with it. So, yeah, we have a bunch of presentations to get through. So what I'm going to do is I am going to start off with our first presenter, Samantha. So, Sam, why don't you go ahead and take over and show us what you learned about?
Sure thing. Hi, everyone watching on the broadcast. My name is Sam. The past couple of days, I've been learning about React, and since we have a handful of students that will be presenting on React, I'm going to actually start off with kind of a basic overview of the core concepts and a couple of the key functions so that you're better able to build on that with other students, and I'll also round it out with a demo using some of those functions. So hopefully you can all see my Sublime screen. I'm going to be pasting some code in there as I go through. So to start off, React is kind of like a library. You use it in the view portion or model view controller setup. And a lot of times React is talked about in comparison with other front-end frameworks like Angular, which we've been working with. But in reality, it's just the view. And you can use React with another front-end framework or with a basic kind of MC model as well. What I'm going to be doing in my demo is a very basic React-only commenting feature on a page. Now, to use React, it's a very new library. It was put out by Facebook, and one of its main strengths is handling a lot of data that can dynamically change. And the reason that React is so good at this is something called the virtual DOM. And the DOM, of course, are the elements that you're going to display on your page. React tries to change your DOM as little as possible. So where in Angular, we had our digest loop and what we call dirty checking, meaning that you were constantly checking to see if values had been updated in your view, and then they were being updated throughout your MVC model as React instead an observer model. And so you have React will build a tree representation of your DOM in memory, and then what it's going to do is every time you want to render that DOM, it's just going to look for changed elements. So instead of changing every single thing that's on your page, think about Facebook and having photos and messages and tons of other things. It's actually just going to say what different element and update that on its own. So it's very fast and efficient at those types of things. So to jump right in, kind of the fundamental of React are components. And components are really easy to make. React create class in some documentation, and the requirements for this are quite simple. You can add inside your create class, curly braces, any method or variables that you want your component to have, but every component must have a render function that you see here, and that's the HTML that you're going to display. So this is a very basic component. When you use a component, you're going to use element by ID. Imagine you had your index.html file and you have a div and it's got an ID content. That's what onto. There are ways to render multiple components or many of your. You have to remember that render really only takes in one element. Some components in a single div and sort of work around it that way. So that's kind of component. Other properties of, we're going to move on to component properties. And those, well, so if you'd like to give your component a property, oops, didn't quite get it, you can simply add it directly inside your div. So here, both user and food are properties on this component. And once you do that, then the component has to those simple. If we wanted to more dynamically update our properties dot user, that's going to be Sam, likes to eat this. I will forward John. Let's see, kind of part of components that I will mention are children. Children are anything between the start and ending tag. And so let me put in an example here. If we have, you can see on line 44, in the close bracket of component, this is the child element. And the handy thing about so events, very similar to what you've dealt with before. They're ways, and you're going to add a function to your component, and then you're going to add a listener on your HTML. So these functions look very familiar. On click, on submit, on change are the most common. So to give you an idea of what that looks like, here I actually built a custom event here, so do something. And I'm defining that on my component. And then on the click, I'm actually running that. That's kind of very high-level events. And the last thing I'd like to touch on before going into my demo is state. And state is really important in React. As I mentioned, React looks for changed elements. And so in order to determine what it needs to render. And so state is a part of that. And the first thing you need to do is on your component, you need to make sure that you set the initial state. So, for example, create a user. We're going to add the method getInitialState. This is a built-in method with React, and that's going to make sure. Oh, sorry, I have some noise in the background. That's going to make sure that React is listening for changes on username. Okay, and that's basically it. Now, once you have that set up, you can use a function called setState. And that's a helper method that allows you to alter the state of a component. Components can modify their own internal state. So setState is a signal to notify your app that some data in that component has changed. Whenever setState is called, the virtual DOM re-renders, and the real DOM is then updated. So to put that all together, this will be a bit of a longer function here. So here we have our hello user, our initial state, as I mentioned before, and we define a second function called handle change, and handle change is actually what calls set state. So in your div here, you can see that on change, that's our event, is going to call this handle change. That calls this function, passes in the event. That calls set state, and that's going to go ahead and update our username. Let's see.
Sam, just so you know, it's you have a 1-minute warning.
Okay, great. So I hope that gave you guys a good basic overview of the core components of React. What I built today and this weekend was very simple, just a simple. So we built things like this, and oh, you know what? Give me just 1 second.
Sam, I'm not actually seeing.
We'll go ahead and give you.
Sure.
Yep, I just had to change the screen I was sharing. Can you see that now, Chris?
Yep.
Okay, great. So I'll do one more quick demo. So that gets added to our list. And a very brief look at the code, because you'll be looking at more of this later. Setting up React is pretty easy. You import the library, include your scripts. Mine is called Sam Says, down here on line 18. Take a look at me. So you can see, looks very similar to the examples I showed. I've got, I'm handling the author change and the text change are 2 fields, and then I handle the submit. In the render, that's where the form is. On submit is tied to the handle submit. I've got a placeholder, etc. So hopefully this looks somewhat familiar. This function down the bottom, React DOM render, that's actually what's going to pull this whole thing together, create kind of the core component, and inject the markup into the DOM element that's in your index HTML. So this is kind of React DOM render is needed at the end of most purely React files. Other than comment form, I have comment list, comment box, and generally comment. So with that, thanks for listening.
All right, great. I would ask anybody if they have any questions, but I think we could kind of defer maybe some of the questions on React until a little bit later. There's a few students that are doing that. Maybe we could kind of pool those questions. Yeah. So Sam, I want you to do us the honor of actually. Could you? Oh wait, never mind. We have the list here. So that brings us to Deepa, actually. So yeah, Deepa, are you all set to go?
Yeah, I am all set to go. So
Okay.
yeah, so I'm gonna
Thanks,
share.
Sam.
I am sharing my screen. Okay. So what I'm going to do is today talk a little bit about TypeScript, just the basics, and my demo is mostly in Sublime, where you can see what I'm doing. I thought that was the best way to learn TypeScript. So what is TypeScript? It is basically a typed superset of JavaScript that compiles to plain JavaScript. This means that you can take any JavaScript code, copy paste it in a TypeScript, which is a .ts file, and just use it directly. So the advantage is, your existing JavaScript code and frameworks can use TypeScript without having any major modifications. So you can leverage TypeScript in any kind of JavaScript application. TypeScript can run on any host, any browser, and it is open source. So why do we need TypeScript, or why do we use it? So bottom line is JavaScript is kind of really difficult to work with complex architectures. Development of application scale JavaScript is quite hard. So TypeScript is a language for application scale JavaScript development. It provides a means of annotating code that can be both human and computer readable and understandable. It is fully compatible with future versions of JavaScript, but with some additional features that make it stand out a bit. So bottom line is TypeScript will make makes complex coding easier, robust, and more manageable. So let us just see a little bit, with Sublime and a little demo what it is all about. So with TypeScript, like I said, any TypeScript will compile to JavaScript. So if you have a TypeScript file, and if you do ts, let's say whatever the name of the file, this will compile it and create a name.js file, which is a JavaScript file which you can execute. But if I want to set up a watch, so every time I compile my, every time I save my TypeScript file, it should compile to JavaScript. I set up a watch, which is using this command, and I'm going to set it up. I'm going to use Node to actually execute my JavaScript. So this is my Sublime, if you all can look into it. And let's start with the basic data types. So TypeScript also has the same basic data types of JavaScript, which is a string, Boolean, number. And I will show you how you. So out here I have defined fname, which I'm explicitly mentioning to be of type string, and I also assign it a value. The lname is is implicitly of type string, and I give it a value. And similarly, we have a Boolean, which is old, and it is explicitly defined as being a Boolean, and out here I assign a Boolean value. So if you notice, once I save this code, and this is my JavaScript, it has compiled to JavaScript. So it has spit out some JavaScript code, and if I execute out here, and I'm doing node test.js, it has given me whatever I have here, first name Joe, some number, some Boolean variable. So I have done console.log, and that is just spit out there. So it's quite simple, as you see. So also we have another data type, which is array, and in TypeScript this is how you will define array, and there are two different ways that you can declare an array. This is the first one, and the second one is actually saying that the elements are of type string, and this is how you declare it. Again, when I save it, and I'm going to come here, yeah, it has the JavaScript code here. So let us also introduce some error condition, because TypeScript has the advantage, it can help you catch all these errors. But one thing to consider is, although you may have errors in your TypeScript code, it will still compile to JavaScript and execute. So let's just go and see what this means. Here I uncommented this code. You see out here I have that it's showing me a red underline under some of these lines, which means I do have an error in my code. And the reason is out here, this ARR2, I'm giving the fifth element of value, a numeric value 10, whereas in line 40, I'm just saying that the elements have to be of type string. So this red underline indicates an error, and if I put my cursor out here, you will actually see in Sublime it's telling you that type number is not assignable to type string, so it actually tells you what the error is. But in spite of that, it does get compiled and I can still execute it. Again, I have a bunch of other things to indicate the errors out here. Array2 has been given Boolean values, which is incorrect. A Boolean variable, which is max out here, has been given a string value. This is incorrect. So I'm going to go to some more data types that we have in TypeScript. We have an additional one, which is a tuple, which is not there in, I don't think it is there in JavaScript. So let me comment some code here. So what is a tuple for? Sometimes you have that the type of a fixed number of elements is known, but the type of the elements need not be the same. For example, here I have defined a tuple, info, and by the way, I can use either let or I can use var. Either is correct. So I have info where I'm saying I have two elements. One is type string and one is type Joe. Sorry, here. This is actually var info. Yeah. Excuse me. Yeah. So this guy. Yeah. So it is string and number, and out here I'm actually initializing it with a string and a number. This is correct. But the first two, right, they have to match because these are the known types. I can also have additional elements in here. If you notice, after Joe 18, I have 90 and Johnny. Now these can be either string or number, but no other type. And if I save it and I execute it, I will see some output in here. So here it's telling me what the values are, and also I have an index for the one at the value for the one at index 1, which is 18. Yeah. Now if I try to assign a numeric value to something like this, if I do something like info is equal to 18, this will give an error because it was supposed to be string and number. And if you notice, there's an underline here, and it actually gives you an error message. Type number is not assignable to type string. So that's the advantage of TypeScript. You kind of immediately know what is going on. We have another data type new in type string, which will compile to an equivalent JavaScript code, but enum is not there in JavaScript. So we have enum. Yeah.
Deepa, I just wanted to. I'll give you. We'll go to a 2-minute warning since I think that's a little bit more.
Yeah.
More notice.
Oh, okay. Yeah. For me, my demo is just this whole thing. What I'm doing out here. So yeah. Okay. So enums are, with enums you can start by default. They start with an index of 0. So something like this is index of 0, 1, 2, 3. But I could have an enum start with an index, which I define explicitly, which is 11, and here it's going to give you, at index 11, whatever the fruit was, which is apple. So let's also go to, we also have another data type in TypeScript, which is any, where you do not know whether it's a string or a Boolean or number, so you can assign it any value. And even if you assign it as a string, the first time you can change it to a Boolean or a number later on. Finally, we also have classes and interfaces, some new constructs in TypeScript. So this is the interface construct. And the way I can use it in a function here, this function is taking coordinates x and y, and it prints out the coordinates. But instead, and it's saying the function is taking a parameter, which is temp. But I can, instead of doing this, I can pass it the interface coord, which is here. I have a defined coord here. I can say it's a parameter of type coordinate, and I can actually use the value of whatever I pass here. So now I'm calling the function with the coordinate here, and I can actually save and execute it. Hold on. Yeah. Now if I execute it, it is actually telling me what my coordinates are. And when I have something like here z question mark, which means this is an optional parameter, I don't have to pass it, but I do need to pass the x and y and in the right order, otherwise it'll throw an error.
Okay.
Okay.
That about wraps it up. Are there any quick questions on TypeScript? No? Okay. Thank you, Deepa.
Thank you.
Okay, doke. So next up we have John, and he will be talking about React. So, John, are you all set?
I am. Can you hear me, Chris?
I can.
Perfect. So yeah, just slack me if there's any technical issues in the middle of the talk.
Okay. Yeah.
My
So
name,
far, I think we're
okay,
doing
go
all
ahead.
right.
Yeah, my name is John Kosmicki, and I'm a student here at Viking. And for this project, I also worked on React, and in particular in the context of the application 2048, which is a game, sort of the flavor of the month in Hacker News and some other kind of geeky stuff, maybe a year or two ago. And it's something that I'm actually substantially interested in independently, mostly because the gameplay is simple but not trivial, so that it actually makes for a very useful proof of concept for any number of kind of algorithmic ideas you might want to deploy. So that said, basically the view in this app is in React, and you can see, I don't know if you've ever played 2048. It has the usual functionality. It's kind of pretty bare bones, but it works not too bad. I didn't put the score in, but that I would probably not take me very long to do. In any case, as a React app, it's very it fits in very nicely with an MVC framework, but it is not an MVC framework by any means of its own. As I understand it, the idea of it is you want to componentize the view for the purpose of, I guess, not even so much code reuse as component reuse, which is to say these tiles or this board or these other things, if you wanted to deploy them in a different application, you could. In this particular case, it might not work as well, just because I probably coupled it a little bit too tightly with the with 2048 functionality that you would have to extract. But in essence, let me just kind of go through this code over here for just a minute. There's two components in this application. The main one is the board, and there's another kind of child component, which are the tiles. The key benefit to using React, is maybe as opposed to some others, is that the data, it works kind of at a component level, so the data is associated with the components as opposed to the application as a whole. Therefore, in this case, like going back and forth between the tiles and the board is supposed to be really nice and elegant. There's essentially two kinds of data in a React component. They're typically differentiated between state and props. And the difference is that state is something that the component itself owns and updates, and props are something that are passed in from higher above somewhere, typically a parent component. In this case, what I'm doing here is the this has a tile, right, and it is getting pushed. The key, the index, and the value are props on the child component, which is the tiles. You can see they get pushed in. They get created here, and then they get used here. Okay, so in this case, whenever you have a syntax like this, it looks like this. I believe is JSX, which is kind of the templating language or that they created for React. It looks like HTML, and it's very close to HTML, but you can do some things that you can't do in HTML. And in this case, this creates a bunch of props, which is essentially data on the child elements, and therefore, in this case, the board controls all the data. To be honest, I really don't think that's the best architecture. I think it would probably be better if the board could be just some kind of generic placeholder, and what I have would be props. Instead, would be state variables on the individual tile, so that the board wouldn't necessarily have to be aware of any of that information, and it could just interact with a separate JS object that I'm calling the model instead. If I would worked on this probably for another hour or so, I would refactor it to do it this way. Otherwise, these here are probably some of the main functions that you're going to use in React. The main one is this render method that you're going to use for just about every React component. The key architecture of a render method in a React component is to return some kind of virtual DOM element that you can position on the page as you see fit. This other functionality I think is fairly typical as well. Get initial state. It just says what's the initial state. Again, it's similar to the default props, except that it references the state instead of the props. This is just an interaction with models, so this isn't really a React function. But these other three, actually these other two are, this component will mount is a useful function because it allows you to have a hook into any kind of functionality that needs to be invoked before the component comes into memory. In this case, I have a model that I want to initialize, so I want to do it here. The other alternative is component did mount, which is similar but slightly different. For the case of did mount, it means that this is already attached to the DOM. So this is kind of gives you a good separation here. Will mount, you might want to use that for just kind of model or data or some other logic that needs to be done. Did mount would be something where you want to somehow interact with your component as it's already been rendered in the DOM. In this case, it's very interesting because I'm adding an event listener to the window, which I wouldn't like to do. I would like to add this to simply the board as a DOM element, but I couldn't get focus on it, so I just put it on the window instead. But the one thing that you can see is that it actually works very well. It's not going to complain about working with other libraries or other frameworks, except maybe Angular for issues relating to it, for Angular, not React. This is an event handler. It's going to be very typical to handle events. Really, to be honest, I didn't really use a whole lot of the functionality, so it looks to me to be just kind of a pretty basic view. But again, I really didn't deploy a whole lot of the functionality for this kind of simple app. If I didn't mention this already, anybody wants to look at the code, this is available at my GitHub account, which is Koziscool, K-O-Z-I-S-C-O-O-L, and the repository is 2048 React. Let's see, anything else that's in here worth mentioning? Not offhand. I think I think that's the better part of my time, Chris. Is there anything else that's worth commenting on, or should I be entertaining some questions?
Yeah, you have a couple minutes for questions, so that brings us right, to a good place for that. Does anybody have any questions for John? Or I mean, like I think we said we were going to pull some of the questions for React, and we might actually be able to gain back a couple minutes if we do that. So.
Okay. Well, either now or later. I'll probably defer those questions to Thomas, but.
Okay.
All right.
Well, cool.
Thanks so much for listening, everybody.
All righty. All right. So let's keep it moving. I think next up we have Josh, and he is going to be presenting Phoenix and Elixir. So, Josh.
Hi. I'm going to share my screen here, and then I'll start. All right. So I did Phoenix, but it uses a language called Elixir, which is one that we haven't really covered much in class. So I'll go really quickly through sort of what makes Elixir different from Ruby, and maybe also kind of similar in some ways. So Elixir is a here. Let's see if I have that pulled up. So Elixir, this is from the Elixir website, it's a dynamic functional language designed for building scalable and maintainable applications. So basically, the key difference here between Elixir and Ruby, or the biggest difference probably, is that it's a functional language. So Ruby and most other languages we've discussed are called imperative languages, and in particular are object-oriented languages. Functional languages are quite different. They're based on the concept of mathematical functions, and that came out of lambda calculus, which I don't know much about lambda calculus, but that's where functional programming came from. And basically what you have to know about functional programming is that a function's output is not dependent on the program state. And so what that means is if you put the same inputs into a function, it's always going to give you the same outputs, regardless of the other state in the program. And so that's quite different from say methods in a class in object-oriented programming, because the object can have state, have properties associated with it that can change, and that can affect the output of functions that are on that object. And so in functional programming, you totally avoid that. You also avoid sort of going the other direction. You avoid side effects. So you avoid having functions that do something other than spit out a result. So basically, there's no basically like in a lot of languages, you'll see functions that don't actually return anything. In functional programming, that idea doesn't make any sense because every function has to return something. So that's functional programming. Elixir is also interesting because it's concurrent, which means that it can use many processes at once, and that really helps with scaling. Let's look at some code, and as you can see, despite all the differences with Ruby, you actually can see that it's quite similar in syntax in a lot of ways. So you define functions with def. There's other keywords like def module, but it's kind of the same idea. And so another thing you have to know when you're working with Elixir in particular is there's a utility called mix, and it's kind of like rake in Ruby, in that it's a build tool and a task runner, and so it has a lot of things, and every project it does a lot of things. I mean, and every project that in Elixir has a file called mix.exs, and basically it defines the dependencies and lots of other stuff about the project. This is from a project I did in part of a tutorial in Elixir. So this is plain Elixir code, not in Phoenix. So just to give you a sense of what that looks like. And one other cool thing about Elixir is there's these things called here docs, and basically it's right in the code you can do this @doc and then triple quotes to start and end the documentation block, and then you can write your documentation right in there, and it can be formatted with Markdown, which is pretty cool. Now to move over into Phoenix. Phoenix is a an MVC framework that's built using Elixir, and it's fairly new. It's still kind of in very active development, but it's already very useful, and it's in some ways a lot like Rails, and in other ways it's not. And it's similar to Rails in that it is an MVC framework, obviously, and it can do CRUD, create, read, update, and destroy. It can, but it also has some built-in features that Rails doesn't, like automatically updating the DOM. So basically, it has its own built-in JavaScript client for the front end, so that when you update something on the back end, it automatically is visible on the front end. So, and it has a templating language, kind of like ERB in Rails, and it's called EEX, and so it's in some way it's very similar, because like your Ruby's RB, ERB, EX, EEX. So and you can see it uses basically the same syntax as ERB as well. So that's a pretty easy transition there from Rails. And let me just do a little demo here. This is a very simple chat application that I created, and I posted a link in Slack. I don't know if anyone was able to sign in, but if you are able to, and you go to that, we could chat back and forth, and it works in real time. So this is basically, this is Ajax. It's using something called a channel, and so a channel is a feature of Phoenix. And I'll show you an example of a channel. So so basically the channel has these certain functions like join, and there's multiple function definitions that are, that have different inputs. But basically join lets you join that channel, and then you have to also define these functions handle in and handle out, and they basically handle ingoing and outgoing responses. So really, a channel is basically like a controller that can go both ways. So it can receive input and it can put out input, and it doesn't just have to be between Elixir applications. In Phoenix, it's typically between the back end that's written in Elixir and the front end in JavaScript. But it could also go to an Android app or an iOS app, or basically anything else you can think of that you could send messages in this format. So this basically identifies which channel, and then you send messages as a payload that then gets handled by this file called socket.js. And so you can see here just an example of what happens. Basically, in this file, this is the view that you can see here. It's very simple, obviously. But basically, these inputs are tied to this socket.js file, and using jQuery, they're linked. And
Josh, just so you know, we have the 2-minute warning.
Oh, okay, thanks. And so you have this function that that basically this function sends. So when you press enter, which is key code 13, it sends the message, and then then it also receives the message back, and so it goes through this room channel, which does this. When it gets the message in, it broadcasts it out. Basically, it broadcasts it to all the other clients that are connected to that channel, and so that kind of allows for very quick responses. Even though this is just like a DOM element, it gets updated instantly. So yeah, and let's see, do we have anything else to show? So just to kind of go through the overall architecture of an application. There's the mix.exs that I mentioned before, and you can put the dependencies here, kind of like a gem file in Ruby. And then you have models, and models are a little bit different because they incorporate a lot of different things that are separated out in Rails. But so you can see the schema right in the file, and there's migrations and everything like that as well, just like in Rails, for database purposes.
Josh, if you kind of want to just give an overall sum of everything.
Okay, right. So, so sort of a takeaway from all this is that Phoenix is a relatively new framework. It uses Elixir, and it's very fast and scalable, and it's known for being similar to Rails in some ways, but more scalable and having better performance. So it's a very useful framework, and I would definitely recommend learning it. So that's what I have.
Awesome, very interesting. Thank you, Josh. Okay, so moving on, we're kind of ping-ponging back and forth between things and React. So one thing and then back to React. And Thomas is going to take us back to React. So,
Yay.
why don't you,
Okay.
tell us what you've been up to, Thomas.
Okay. Firstly, hello everyone. My name is Thomas Lowe, and I'll be talking about React. John and Sam did a great job, but I think I can talk about a few other components not mentioned. So to start off, I'll talk about the build process that goes into setting up your React app, and I'll also talk about routing in general, and also making HTTP requests with Axios, which is a client, HTTP client library that you can include in your React app. Okay, so starting off with the build process, I'll go into that now. And as you can see, to build your React app, firstly, there's this thing called package.json, and for the Rails users out there. This is similar to a.
Thomas, I don't know if anybody else can see your screen, but I don't.
Oh, oops, sorry.
Yeah, if you could screen share.
Yeah, I forgot about that. Okay, so this file is called package.json, and what this is, similar to Rails, this is a gem file, and as you can see, these are all the dependencies that I'm using here, and what's great about this is instead of actually downloading the modules or the libraries, which is all listed in node modules, you can ignore this in your .git ignore and just include this in your include the package.json, and when someone else clones your repo, they can just run npm install and all their dependencies will be included. Okay, now I'll move on to Webpack, which is a module bundler, and it's quite useful when using React because like Sam and John mentioned, React uses JSX, and JSX is not really HTML. It's a way it converts to JavaScript, which eventually renders a virtual DOM, which is different from the actual DOM. And I'll provide a short example of that right now. So if you can see, this is my render function here, and what I'll do is I'll copy and paste this and show you. Oops. So this is the JSX that gets translated to JavaScript, and it doesn't just happen right away. You need something to actually convert it into this JavaScript, and that's what Webpack does. And if I can go back to that right now, this is the whole process, and I'll explain the path of how this happens. So you always have to have an entry point, a starting point, which will be index.js, and if we go to that really quickly, it's nothing but this is very clean. And next you need to know is the loaders, and this is where it actually converts your JavaScript files into JavaScript, or your JSX and your JavaScript files into JavaScript. And so what this loader does is it targets this JS file. This is just regex, by the way, and excludes the node modules because that's where your modules are. And it loads this Babel loader, which we included in our package.json here. So it's very convenient that way. And what this ends up doing is it converts it and it outputs it into this file called index_bundle.js, and this is all the JSX that's converted to JavaScript. And if I go quickly there, as you can see, this is just compiled version. So if you're familiar with Sass and CSS, this is pretty similar to that. And I have a convenient plugin called HTML Webpack plugin here, which injects it into uses the index.html as a template and actually injects it here, the script that we need. So this is the actual file that's being shown in our local host. And I'll do a quick demo of what I have. So this is an app that I made by taking this course on React Fundamentals, and what it does is it's pretty simple. You can type in a username. I'll type in mine, and you can also type in another person. So, and what you do is you can battle each other, and each player will get a score, and the player with the higher score will win. And as you can see, I lost here, and you can also start over. So that's the basic application. And if you've noticed, there's routing right now. So if I go to the home page. If I click Get Start, it will go to Player 1, and I'll show you the whole routing that's done in this application. Let's see. So this is where the routes are at, and let's see. For the routing in React, you have to include them. So everything that you need, you will have to include explicitly, just like this. So I'm always requiring React router and React itself, and I'm also including index route and hash history. And these are where my components live, so I explicitly require those as well. And for setting up your route, you always need a router, and I'm using hash history, which allows me to use the hash for the URL. And this is the main route. So anything under this is going to be a nested route. So if you're familiar with Angular, this should be pretty similar. And I'm stating the path and the component which is going to be displayed for that current route. And if you can see, this one's slightly different. It shows up as index route instead of just regular route. And what that means is whenever there isn't anything showing here, this becomes the default. So if you're starting from the home page or the main page, it should always show the home component nested within the main component. And you might be wondering, how is this even displayed? So I'll go into the main page really quickly.
Thomas, we're at a 2-minute warning, just so you know.
Oh, okay, that's pretty cool. Okay, so yeah, this.props.children, it's similar to UI views for Angular, and this is where everything is getting injected. I guess I'll move on quickly to containers and components. So in React, there's the practice is using two different components. One is your smart component, which contains all your states and functions, and there are the dumb components, or usually called presentational components, or stateless functional components. And if you can see here, this is my container, which is the smart component. I have all my logic, business logic handled here, and all my states. So if I go to this one, I have states and states. And if I go to the dumb components, all it does is it renders HTML, or not HTML, but JSX. And one thing cool that I want to talk about is prop types. And what prop types are is it's a way to check the properties that you pass into your child element, or more specifically your children component. You can check its type and make sure that it's required. What's useful about this is if you pass in a variable or type that doesn't match this, it will show a warning in the console.log, so you can know that there was a error in that sense, or in that aspect. And one thing cool about child components or dumb components is you can just call it a function and it will render as a component. You don't need to create class for this. And what classifies these components as dumb components are, all they do is just handle the rendering, and they just have prop types.
Okay. Thomas, we're gonna have to stop you there, but yeah, this looks good. It seems like you got a lot done. Since you'll be the final of the three that did React, I'd like to field any questions that anybody has about React now, if there are any.
What's the scoring mechanism for GitHub Battle? That's what I want to know.
Oh, that's actually really simple. It's just it goes and compare calculate. There we go. It's just getting the followers and multiplying the followers times 3 plus the total stars. And yeah, that was pretty much it for that. Any other questions?
All right. Well,
Okay.
thank you, Thomas.
Yeah.
I think up next, yep, we got Kelsey, and she's going to be telling us about Vue. I think we lost somebody. Oh, Kelsey, you're with us, so.
Hi, hello everybody, I'm
Take it away.
Kelsey, and hello everybody, I'm Kelsey, and today I'm going to be talking about Vue. I should actually, hang on, let me zoom in on my code so you can see it properly. Yeah, so Vue is basically the front-end JavaScript framework. A lot of it's going to look pretty similar to stuff like Angular, if you know about that.
Sorry to interrupt. Can anyone see Kelsey's screen?
Oh, really?
I don't think you're screen sharing.
Me-
I don't know if you, yeah.
Is that's better?
Yep, there we
There we
go.
go.
Okay, yeah, so basically it's similar to Angular, but it's very lightweight, very fast. One thing that's interesting about it is it has a design pattern that's slightly different from the MVC model view controller. It's abbreviated as MVVM, which is model view model, with view model being one word. And it's kind of a subtle difference, but as I understand it, basically it means that the view and the model are more tightly coupled than it would be with a controller. Like, for instance, one view model is only going to have one view that it interacts with, whereas a controller can have multiple views and stuff like that. So over here you can see that basically the core of how it works is creating these view objects, and they have several different traits. So L here is the element that's going to be basically operating on. So here it's to-dos. So over here you can see that I've created this big div. It's a container, and the ID is to-do. So everything within that div is basically can access the data and methods on this view. So then we come to the data, and basically any data that you want to be using inside this div, you want to just initialize here in the data object, because if you add in data later, unless you do it very specific way, it's not going to be able to watch and update that as it would if you said it previously. So you really should just have that all at the beginning. And then ready, I'm actually not using this right now, I was using it before, but this is basically a function that will execute when the page is completely loaded. And here we have the methods. Similar to data, you want to define these beforehand, and these are the methods, like if you want to define them by clicking a button, or if you just want to use these methods for anything, then you'll also want to define them. And there are various other parameters they can have too, but this is a simple start. So I can just run a demo, go to store, eggs. So this is basically a fairly simple to-do app, but you can see it's very snappily. And can delete ones either individually, or you can clear off all the completed ones. So to delve into a little bit more closely how that works, again, very similarly to Angular, you can bind these input models to properties. So in this case would be the new to-do name attribute, and similarly with the description and date, and it will initialize if completed false. So it's a very simple two-way data binding, and you don't really have to worry unless you get really complicated with it. You don't have to worry about it getting like detached in any way. So it's very simple. And then here you can see on click, we will add the to-do or clear the completed items. You can iterate over the elements of this to-dos array and display similarly here. Yeah. So a very cool thing also is that the core functionality is very lightweight. So if you want to, have a more complex app with like routing, you would install a separate like view routing add-on and stuff like that. So it's basically super lightweight, super fast, and can scale if you need to do more complicated stuff. So that's a fairly brief overview, but I actually thought it was really cool. How am I on time? Do I have more time? Does anyone have questions?
You actually have plenty of time. You have like better part of 5-6 minutes left. But yeah, that just means that you're being very concise. So yeah, feel free. I mean, like if you have anything else that you want to talk about. If not, maybe we could have some questions. But yeah, is there anything else about Vue or your app that you'd like to talk about or that you learned?
Let's see. I really thought that was going to be longer. I'm sorry. No, I can't think of anything in particular. It really was basically, as I understood it, like a very stripped down version of something like Angular, so there were a lot of similarities that I didn't necessarily want to repeat.
Okay. Well, yeah, then we could definitely open up to some questions. Does anybody have questions for Kelsey about Vue and her app?
Yeah, I was developing in Vue as opposed to Angular. Was it a lot more productive?
I would say like there were some difficulties. Like honestly, I spent the better part of an hour like with like a typo that I think was from an older version when they changed the syntax. So that was an issue. There wasn't nearly as much I guess not documentation. The documentation was pretty good, but when I ran into other issues, searching on Stack Overflow, there wasn't as much help there. So I would say those issues, took up a lot of time, unfortunately. But as for the general structure, you can see this. It's fairly simple and pretty intuitive, I think, once you get the hang of it.
Cool. Thank you.
Yeah, I think that's a good point. I think that's a good point about the smaller frameworks. Like no matter how well documented they are, most of the time those frameworks have only the sunny day use case documented, and they don't spend too much time talking about when things can go wrong. So that is something to look out for when you're picking these kinds of frameworks. Are there any more questions for Kelsey? Okay. Well, thank you very much, Kelsey.
Thank you.
Okay. We're going to keep it rolling. Next up, we'll have Andrew, and he is going to be telling us about Aurelia. Andrew, how do you pronounce it?
I don't know. It's Aurelia. I don't know if I'm pronouncing it correctly, but I'll just say Aurelia for now. Okay, so let me share it here. All right, hello everyone. I'm Andrew, and today I'll be talking about a front-end framework called Aurelia. All right, so a lot of the stuff I'll be talking about is kind of laid out in my blog. It's strikingme.tumblr.com, so feel free to go there to get a step-by-step on how to build a to-do app. And so here is a little demo, just demonstrating what I built. It's a very simple toy app. There's a very simple data binding to form inputs, event click binding, so it'll display the name dynamically. It has routes, built-in route system. So I built a very simple to-do app. So can very easily have persisting data. So even when you're switching amongst different states, here's kind of like I make API calls to GitHub. This is actually part of the getting started guide. So this page is actually part of the tutorial. So that's kind of nice. I won't be going over this, but I will be going over the To-Do app, which was not part of the tutorial. So the To-Do app, you can I managed to build a simple CRUD to-do functionality. So you can, when you click on the task, it immediately flashes true, and you can delete and create new tasks. And so let's get started. So here's kind of like the project or the app setup. The JSPM is JavaScript Package Manager. The framework uses it to get all of the dependencies it needs to run the app. So if we take a look at the index file, it's pretty simple. Everything is just base HTML. What's interesting is the body tag here, the body section. So basically, lines 10 and 11 loads up pretty much the dependencies and the configuration for the app. The system.js.import loads a module called Aurelia Bootstrapper, and it looks for an attribute called Aurelia app. And just like in Angular, it replaces it. It looks for a component called app and sticks it in the DOM at this location. And a web component is basically composed of two parts, a view model and a view. The view model contains JavaScript code, typically written in ES6 or whatever, and TypeScript. Aurelia can handle both. And the view is just simple HTML that is just rendered to the DOM. So let's take a look at the app.js component. So the app.js component contains the basic setup and the layout of the routes of the whole app. So you can ignore the basic syntax. Basically here kind of lays out the roadmap of the app. So the route specifies, so each of these things is a single part of the app, so a single view or component. The route lays out the URL of the page. You can ignore all of this syntactical sugar. Basically, you can set up the routes if you refer to the documentation. But basically, I have 3 routes: the welcome route, the to-do route, and the users route. And basically, if I go to the app, go to the welcome route, the significance of this syntax is that I can either have an empty URL or a welcome appended to the end. So if I think I could do this, it should yeah, if I replace to-do with welcome, it should also take me to the welcome route. Or if I take it out, it should again take me back to the front page. So that's pretty much how route works in Aurelia. Pretty simple. As for the template, this is just basic. So Aurelia templates kind of work like if you're experienced in Rails, like partials. Every HTML view component of is encapsulated by template tags. So you'll always see this template, a pair of template tags enclosing whatever HTML you're rendering. And just kind of similar to Angular, you can actually call expressions. In Angular 1, there was the double angle notation, but in Aurelia, it's actually quite similar. There's the single angle bracket notation, so it functions exactly the same as you would think in Angular. And so router.title just pulls in the title attribute of the route, and so it displays. So when I click on a certain link, actually this part generates the links of the nav bar. So it's actually this lays out the links for each part of the app. Other interesting things to note about Aurelia is how similar it is to Angular. So here in line 23, there is a repeat router.4. So this is in Angular 1, you'd use an ng repeat, and the syntax is almost exactly the same. And so router.navigation is just an array of routes that's returned from app.js. So app.js contains all of the data and the JavaScript that is pushed up into the view. So there is a separation of roles. So li repeat 4 generates lists for each element in the router. So right now there's 3 routes. So there's going to be 3 li elements generated. And so there's also, yeah. And so basically, if I go to the to do route, so if I go to the app, click to do, basically this will go and call the to do component, which again is composed of the to do JS and the to do HTML component. It's the to do component is broken up into the JavaScript and the view, or the view model and the view. And so the JavaScript is actually written in ES6. So if you're not, this is kind of like the newer syntax for JavaScript. So I have a link to shortcuts on how to kind of understand this. For now, export class is kind of like a syntactical sugar for prototyping, prototypical object-oriented JavaScript. So you can actually think of this export class or class to do as a constructor pattern that you would normally see in JavaScript. And export just makes it available to the app. And so basically you can construct functions and constructors for this component. And so I have a very simple add to do function and a delete to do.
We're about at our 2-minute warning, just so you know, Andrew. Okay,
sure. And so basically how this works in the view is, if I go to the to do HTML view, I have a button. Where is it? So on submission of this form, I run this add to do function, and basically it just runs the function defined in the view model, and this function has access to the back end array of to dos, and so there's pretty much the view model sets up all the data and behavior for the view to implement. And so also there's also value.bind, and this feature is pretty much similar to the ng model feature in Angular. And so this basically has a two-way data binding set up. So when you type things into here, it updates automatically. Although here's a better example of what that does. Yeah, and so that's pretty much it for my presentation. Does anyone have any questions? What I actually like about Aurelia is that most of the code is actually just raw HTML and JavaScript, so it really gets out of your way in terms of frameworks. So it's kind of a joy to learn Aurelia.
I had a quick question. So you mentioned there was two-way data binding.
Yeah.
So are they using something like dirty checking, like Angular, to do that?
I believe so. Yes. It's quite similar to Angular in that regard.
Okay. Cool.
Yeah.
All right. Thank you, Andrew. Okay. We have a couple more presentations left. So we're going to move on to Julia, and she's going to be talking to us about Scala. So, Julia, do you want to take it away?
Yes, great. Thank you very much. Thanks for your patience, too. You guys have all sat through a lot of presentations, so I'll try to keep this very interesting. So, yes, I decided to focus on Scala, which is a combination of the words scalable and language. It's a statically typed language, and it fuses object-oriented programming with functional programming, so a little bit of what Josh talked about. Scala does get compiled down to Java bytecode and then eventually run on a Java virtual machine, which means that you can have true concurrency. So, that great buzzword that everyone's talking about. But it really does allow for many processes to be running all at once. So when you talk about a statically typed language, you need to talk about the type system. So a statically typed language, the types are checked at compile time. So you can see on the right, you have Scala is a statically typed language, and then on the left, you have Ruby and JavaScript, the ones that we're familiar with. And those are dynamic, which means the types are checked at runtime. There's a second axis, which is strong versus weakly typed. And so a strongly typed language will throw an error if the argument passed doesn't match what it's expecting. And a weakly typed language has few rules around types. I'm sure you guys remember that from JavaScript when you have strings when you're expecting integers. So why statically typed language? You can see from that cartoon, it might feel like you're labeling everything. This is an integer, this is a string. And so it doesn't quite look like this in Scala when you're typing out code, but that is what it looks like at compile time. Literally everything is known. And so what are the advantages of this? So types impose constraints that help enforce correctness. You get earlier information about programming errors, which leads to fewer bugs. And you also get really helpful information about errors. So what this means is that you need fewer unit tests, and it can also make your program run a little bit faster because it's not checking everything at program execution. So just a little bit of background, where does this fit into the ecosystem? So there are a lot of companies using Scala today, some of the big ones you might recognize. Twitter, LinkedIn, there's also Verizon, Airbnb, you can see Foursquare on there, Meetup, Netflix, Intel. A lot of people are really investing a lot of time and energy into learning and teaching Scala. So there are a handful of Scala frameworks. You guys might have heard of Play, which is a full web framework. Scalatra, which probably sounds familiar. It's inspired by Sinatra. Akka is a distributed actor model. So it would be used with other frameworks, not really on its own. Scaloid is for Android development, and then there's HTTP4S, which is a predecessor of Scalatra, similar in use case. So what does Scala look like? It's similar to Java, if you guys have ever programmed in Java. You can see Java on the top there. It's a basic for loop. There's definitely more declarations than you are used to in Ruby or JavaScript. I think the for loop is really different in Scala, so it's for val arg in args. It takes a lot of getting used to. So we'll start with a much simpler hello world example. So you can use the REPL just like you can with Ruby. You just need to download a certain number of things, and then you can type Scala into the prompt. So you can see on the top example, you're just saying print line hello world, and you're up and running. So for production use, code is compiled and then run as bytecode, as I mentioned before. So you would make that hello world.scala file, you would compile it using Scala C and then the file name, and then you run the file using the word Scala. So a little bit more about the syntax. Value types are capitalized, methods are preceded by def. There's a difference between val and var. Val is for immutable variables and var is for mutable variables. This one's similar to Ruby. Return is unnecessary, but allowed. And array access looks a lot different because arrays inherit from functions. So you're going to see array of I with parentheses rather than array of I with brackets. And so a little bit more about the data types. The Boolean data type is called a sum type, which means that it can only be true or false. So the answer to what is false in Scala is literally just false. There's nothing like falsy. You're not going to encounter an empty string being false, 0 being false. It's truly just false data type. So I'll roll into another example here. So here's a really simple validate age function. And so it takes one input age, which is an integer, and so you have the capital I for the int for the data type, and then it returns a Boolean, capital B for the data type there, based on the evaluation of the right-hand side. You'll notice that we don't have return there. And so what happens if we run this function on an input that is not an integer? So if we try to run validate age of the string of 65, I'm sure you guys can guess this, but we get a type mismatch. So we were expecting an integer, and instead we got a string. And so this is something that's known before your code ever gets to humans. You know, it's going to be flagged by your compiler. And so this raises a question, like, do you have to rewrite a function for every single type you want it to be able to handle? And so luckily the answer to that is no. You can write functions that take a generic type. So this is a map function, which everyone is probably familiar with. It's going to take two arguments, a list of generic type A, and the second one is a function that transforms type A into type B. And then you have, after the colon is what you're expecting to get returned, which is a list of type B. And then the right-hand side is what actually gets evaluated. So yeah, a little bit about that previous example. It's called parametric polymorphism. And so that just means that you can make your code more expressive while still maintaining type safety. And so if you're a functional programmer, you just call that polymorphism. When we're doing things in Ruby and Rails, which is object-oriented, our polymorphism is actually subtype polymorphism. So I thought that was really interesting. I just wanted to bring up that there's different types of polymorphism. Actually, how am I doing for time?
So we have about 3 minutes left.
Okay, cool, thanks. So I'll roll it straight into Play. So Play is a stateless MVC framework. Of course, like every framework, it brags about all the things that it's great at. The setup was non-trivial. You've definitely got to have a lot of Java pieces playing nicely together. It does have a great GUI, which is Activator. You also need CoffeeScript. Other things you need would be patience and Google. I had a lot of trouble getting it to work out of the box. And so here's the Play file structure. So you have your general app folder. Actors is going to be an example of that concurrency that I mentioned earlier. So in the example that I'll hopefully show you in a second, it's a stock simulator. And so you actually generate one actor per stock. So that means that you can interact with things, and they're completely separate from each other. So that's one of the pluses of Play. Assets, like you expect, is just JavaScript and CSS. Controllers, similar, just like you would expect. Utils, things not specific to this app. And then the views compile down to HTML, like we're generally familiar with. So the Play demo here, over here. So this is the activator, the GUI that I was mentioning. You can build your code, run it, see all of your error messages in one spot. And then the default local port is 9000. So over here you can see that each one of these stocks is completely separate. They're generating different random data. I can flip them around, and they come back and they're up and running immediately. So I can add stocks to this, and yeah, same thing. So that just generated a new actor, and yeah, that's it for Play. Do I have any more slides?
Cool. So we have
Questions.
about a minute left. Yeah, I think yeah, if we're right in line with questions, let's do that.
Cool.
Does everybody have any questions for Julia about Scala?
Yeah, that seems really cool. So, what? Those were actual like live stock feeds, or was it just random data?
That was just random number generator, not actual stock feeds.
Cool.
I can show you. So, where was it? Oh yeah, so it's in utilities. Fake stock quote is just a random number.
And what are you piping that into? How are you graphing that?
So that, It's a good question. This was all generated for me, actually. So it's a whole bunch of CoffeeScript that's doing the animations.
Oh, okay. Is it like a library or something?
I'm not sure. I will look into that and get back to
Okay.
you.
All right. Do we have any more questions? All right. Thank you, Julia.
Great, thank you.
All right. We are down to it. We have our last presenter, Kit Langton. You're going to be showing Swift, right?
Yes, Swift and Xcode and all that stuff. So I'll just get to it, share my screen. And I'll start with, I guess, with the presentation of what I made, and then we'll kind of work backward into the into this madness. Can everyone see my screen?
Yep, looks good.
Okay. Okay. Screen stuff you see is comments, but you can ignore everything on the screen for the current moment. I'm just going to share what I did. Okay, cool. So this is the app I made. It's, I guess, a flashcard app, nothing too complicated. It leaves some features, but the basics are there. So I could add new cards. What did we just learn? I don't know. Concurrency, yeah. Multiple processes. Doesn't really matter. So I'll add that, and there it is at the top. Yay, concurrency, multiple processes. You can go back in there and edit if you want, and then save it. Multiple frogs. I don't know. And now there we go. It has a different thing. I could change the name. Bunch of frogs. This is multiple frogs. And there we go. Now it's changed here. So that's something that's cool. iOS has a lot of really nice animation frameworks, so you can have these like interactive transitions. Not like anything beyond the basic things you've seen all the time. Like this comes for free, basically. There are lots of interesting sort of parallels. I mean, because we're all familiar with web programming at the moment, and there are lots of familiar parallels, but also places where it diverges completely. But like where you'd want to each over a list or something in Rails and make table rows. It's kind of what this is, except because it comes with part of this this UI framework. It gives you some other features but it's also there is a lot of setup you have to do. Anyway, then when you click the study button down there in the bottom left, it will pick some cards randomly, and I can tap on the bottom to show the back or the front, and if I tap on the top, it'll show the next card, and it'll kind of just randomly go through these until you get to the end, and then it will automatically go back because it knows it's done. So that's basically all the app does. You can delete things too. That just comes for free with the basic list view. But yeah, I'll try to explain as much of the code as I can. Oh, and it has landscape view and all that. So yeah, so I guess the first thing is kind of like, let's start at the HTML comparison. They have these nice GUIs called the storyboard, which is kind of like a WYSIWYG. It's kind of like what you see is what you get, except not really. What you see is kind of what you get eventually, depending as long as you pipe things correctly. Because you can kind of see some facsimile of my application, but it's kind of broken down into weird pieces, and there are all these extra pieces. But yeah, basically, this is where you lay out your app in general, but then there are some programmatic things you can do to override things later. For instance, oh no, it's back. Well, actually, that's not a bad thing. So so for instance, this new card screen is obviously the one right here. So there's a front and a back, and there's a save button. However, if I were to click on a card, I actually never changed that to say edit because it's saving makes sense both times. Oh yeah, okay. So when I hit a new card, it says new card, but then when I click on one, it says edit card up top. So there's a little difference, even though there's only the new card screen. But because I'm accessing it from a couple of different places, it allows you can programmatically change all these elements. So for every screen, it's basically linked to one of these view controllers. It's kind of like the view model everyone was talking about. Every view has its own view controller to sort of define its logic. So if I go over here, and this is the most fun part of Xcode, is that on my tiny screen I can quickly have absolutely no space whatsoever, like when I pop open the assistant editor over here, and it's great, and I'm claustrophobic. I'm going to get rid of some of this. So let me hide some stuff. Make it, that's ridiculous. Okay, so here I am in this new card view controller, and this basically sort of controls the logic for this new card over here. When you click the Save button, because I'm using this same view controller for both an edit and new action, it does a couple of different things depending on whether or not there was a card that already existed. But basically, it does some saving. One of the most fun things to learn about, or frustrating, and are just endlessly confusing things, is just all the new conventions, because it's like a complete divorce from the web framework world. So there is an SQL server somewhere deep back in there, but it's all nested underneath these. Something called core data is the structure you use to interact with the SQL database. You have to set up this something called a persistent store coordinator, which works through a persistent store, and that's allowed to touch the SQL database. But you don't even touch the persistent store coordinator. You touch something called the managed object context, which operates on managed object models. So that's a whole bunch of. I mean, you can see how verbose everything is, and it seems insane. But the great thing is, and why it's less insane, they're verbose because it's explicit and it's semantic and it's human readable. You know, once you know what persistent store coordinator does, all of its functions, they follow a similar pattern, and it's actually quite sane beyond, you know, once you get it into your system like anything else. And yes, so if you because everything's statically typed as well in Swift, there's type. You do have to list the types for things. So this var card to edit is going to be a card eventually, so that it knows that it has a front and back value. So card, if I do card, and then once my computer realizes what's happening, oh sorry, card to edit. So I can do front and back, and it can complete all that. And same with all the frameworks and everything. So you don't have to eventually type out all of the crazy things. You can do, like if I want to do some animation, it gives me all of these different options, and then it'll sort of fill in everything, and it'll tell you exactly what you need to put in there, and it'll suggest things. It's super helpful and cool. So it balances out, and it kind of is just a net benefit in the end. Oh, how am I doing on time? There's so many places to go, but I'll just pick one more place.
We're around 2.5 minutes, 3 minutes. Yeah, kind of you know, like if you want to get to summing it up, and maybe we can have some extra time for asking questions. It's up to you.
Okay, yeah, I'll try to sum it up. I just think I want to show off one more sort of concept, which is kind of interesting. So it's basically the movement between the list and this view. Like, how do you move between views? How do you hold on to your data, right? Like, if this were HTTP, it would, you know, if this were Rails, when you went here, it would, like, you'd know the ID of it, and then it would basically look up the card model and return that to the server again. So a lot of back and forth. Obviously, you don't need to go through a server because it's all on the same device. It's all in memory. But, you know, because it's nice and object-oriented, there's a bit of you've got to be a little clever about it. There's some setup. So if I go back to this storyboard over here, and if it loads, and if it's is it tiny? Is it off screen? Where is it? Okay, here we go. So here's kind of that table view, and it links to the actual. When you click on a card, it goes here. So there are these things called segues, and that kind of defines the paths between things. So when I click on a card, it activates this edit card segue. So I'm just going to sort of describe that process over here. And you can have different segues. And every time a view controller a view is left, this prepare for segue method is called. And you can switch on this thing called the segue identifier. So basically, when I edit a card, I'm doing this block of code right here. So you are getting kind of you have this cards array that defines what populates the table. These where are they? Well, it's somewhere. Anyway, so when you click, you know the index path for the selected row that you selected. So it's just 0 through whatever 8 or something. And then I can get the object, which is the card, through this controller, passing it the index. And because it's typed, you have to sort of cast it as the type. And this is kind of useful because it protects you later on. And then, I'm just going to focus on the important bits. This controller is the destination view controller. That's where we're going. That's this page. So we're starting in one controller, which is this entire file. It's getting the prepare for segue method called, and then we're adding this card to edit on this controller. So that basically gives it everything it needs. And then when that controller loads, it sets itself up by there's a viewDidLoad function, which basically uses the card that it has to populate these text views, which are editable. I guess I'll stop there. That can go on for a long time.
Well, yeah, it's very interesting stuff. Does anybody have any questions about this? Anybody want to ask any questions about Swift?
Yeah, I have one question. I noticed that sometimes the navigation controller had a question mark after it.
Yeah. That is an interesting idea. So this is something that's a pretty cool concept. That's I don't know if it's unique to Swift, but it's the first time I've encountered it. It's a concept known as optionals, which is part of their type checking system, and it helps for compiler safety and things like that. But I'll try to explain it. Basically, in Rails, like when you do stuff like this, like checking if something is nil all the time.
Yeah.
An optional is basically like a programming level embodiment of the concept of whether or not something might exist. It's optional, right? A card could exist here, or it could not. Like I could have accidentally instantiated this without a card, and that would be bad. So basically, whenever you have an optional, you need to do something called unwrapping it before you can use it, and you can kind of put it in these blocks. So where's my card to edit? Yeah. So I have an example right somewhere. Okay, viewDidLoad. So yes, if let card equals card to edit. So card to edit might be a card, right? Or it might not be, because this view could either be used for editing a card that already exists, or if there is no card, it just won't do anything. So basically, if the card, if let syntax implicitly unwraps the optional. So this card to edit is an optional, and now if it exists, the card to edit is going to be set to the variable card, and then it's going to run the inner block. So that's basically what it is. They're all over the place. They actually are really helpful. At the beginning, they're really confusing, but yeah, there are also some other things you can do. And if you see an exclamation point, that means basically you no longer have to check. You're telling the compiler just unwrap this all the time. You can run into some problems that way if you don't actually mean to do that. But like in certain cases right here, like the text view is always unwrapped because this comes for free from the storyboard. So they don't need to question whether or not that is optional. You just can trust it. Otherwise, something terrible is wrong, and it's going to fail anyway.
It's kind of like the bang methods in Ruby, where like there's an associated error if things go wrong.
Sort of, yes. Except it actually does do something rather than just being a sort of convention. But yes, it's danger potentially.
Thanks. That's pretty cool.
All right, great. Well, this has been awesome. I'm very pleased with everybody's presentations. I think you can all give yourselves a round of applause.
Great job, guys.
Good job, everyone.
All right. So yeah, I guess. Dara, did you have anything that you wanted to cover? As part of the review?
No, just wanted to say thank you. I mean, do you feel comfortable enough that we can go ahead and wrap it up?
Yeah, I think so. Does anybody have any questions about anybody's presentations? Any thoughts? Anything?
The
Okay.
first 5, do it again. Just real quick.
What's that?
For the first 5, just do theirs again. I missed it.
Oh yeah, yeah. Apologize for the room size here. Apparently, there's been people waiting on the outside to get in, but it's something that we have no control over at this point.
It's okay. I had a pizza.
That sounds good. Okay, yeah, I don't have anything else. If you want to kind of, Dara, did you say you had something to say to kind of like wrap things up?
Yeah. So first thing, just thank you all the students. Like amazing, kick butt presentations. I actually learned a lot, as usual. Then I wanted to thank instruction team, Chris and Ander, and founder teacher Eric Troutman. And then next, all of you as the audience. So whether you're also potentially students, you can come on in, or you're just looking and you're current developers, or you're just curious about coding in general, just thank you for dropping by and thank you for watching what will soon to be a recorded teaching. And if you have any more interest in Viking Code School, again, I realize I forgot to introduce myself at the beginning. I'm Dara Sanjay. I am the program coordinator with Viking Code School. You can go to vikingcodeschool.com/program, find out more information about the full-time immersive 4-month training or the new part-time flexible option. You can go at your own pace. Thanks so much, and we're signing off.
Yay.
Thank you, Dara.
Bye-bye.
All right,
Wait a second.